Hello, future engineers. This is Vitamath 8. And if it is your first time in my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to become engineering students in the future. And I hope that this series of problems that I uploaded in Vita Mathematics will help you in your preparations in engineering life. I hope that the problems will develop your thinking skills, though some of the problems here are simple, but I also include challenging ones to steer your minds, and I hope that it will help you develop your thinking skills, especially in mathematics, needed in engineering life for you to uh, easily understand the principles in engineering subjects, especially statics, physics, and so on and so forth. So mathematics is an important part of your preparations. So determine the measure of the angle theta in many ways. AB is the diameter of the circle and O as the center. So though there are other ways of determining the angle theta, I'll just present the solution here in many ways and the best way I can. So first, let's have definition of inscribed angle or peripheral angle and central angle. So if this is 15 degrees, then this is the center. 15 degrees is an inscribed angle subtending this arc AD. The center also subtends the same arc. So therefore, the measure of the angle, if we connect O to D, which is which is the radius of the circle, this is 2 times 15 degrees. So this is 30 degrees. Because this triangle AOD is also an isosceles triangle, and one angle is 15 degrees, so that is also 15 degrees. Therefore, the measure of this angle here, ODC or OC or CDO, is 180 degrees minus 30 minus 20. So angle ODC is 180 degrees minus 30 degrees minus 20 degrees. So angle ODC is equal to 130 degrees as shown. Then 130 degrees plus 15 degrees is 145 degrees. So 130 degrees plus 15 degrees is 145 degrees. Another way of getting 145 degrees, it is 180 minus 15 minus 20. That's also 145 degrees. So if this is 15 degrees, in this triangle O or EOD, EO or OE is radius, OD is radius. This is an isosceles triangle. If that is theta, the whole of this is also theta. Now, the measure of this angle is 180 minus 15 minus 130. 180 minus 15 minus 130 is 35 degrees. Therefore, because we expect that the measure of this angle is also theta, we can now find theta. It is equal to 35 plus 15 degrees. So theta is 35 degrees plus 15 degrees. The whole angle here must also be theta because this is an isosceles triangle. So therefore theta is 50 degrees. So that's one. That's one way. The other way is because this is 35 degrees and 35 degrees subtends this arc AE, which is also the same arc subtended at O by this rays. So therefore, this is 2 times 35 degrees. So this is 70 degrees. And if we connect a cord from B to E, and this is the diameter, the other cord, it also subtends this arc. Therefore, the measure of this angle is also 35 degrees. So that's 15 degrees also because at A, BD is an arc subtended by 15 degrees peripheral angle or inscribed angle, which is the same angle here. These two rays, two chords subtends the same arc, so that's also 15 degrees. Then that's also 35 degrees because this arc AE is subtended at D by this angle of 35 degrees. So therefore, this is 2 times 35 degrees because this is a central angle. So this is also 35 degrees because uh, this is 35 degrees because 15 degrees plus 35 degrees equals 50 degrees, which is also the same as this. It is also the same as this because this is an isosceles triangle. So that's 35 degrees, and therefore this is 2 times 35 degrees, 70 degrees. Then another way of computing theta is it is also 35 plus 50 degrees. Then in angle DOE, DOE, DOE is 180 degrees minus 70 minus 30. So this is 80 degrees. Angle DOA is 80 degrees. And that 80 degrees here is this angle here. So in triangle DOE, assuming we do not know yet theta, but we know that this is an isosceles triangle. So let us say that is theta, this is also theta, and we have found this which is equal to 80 degrees. So therefore, in this triangle, theta plus theta, 2 theta plus 80 equals 180 degrees. So 2 theta plus 80 degrees equals 180 degrees. Minus 80 is 100 degrees divided by 2. So theta is equal to 50 degrees. Then in this triangle, which is an isosceles triangle, we connect chord AE. So this is 70 degrees. Then these two angles must be equal. So let us say this is alpha. Alpha plus alpha plus 70 degrees equals 180. So 180 degrees minus 70 degrees equals 110 degrees divided by 2. So therefore, this must be 55 degrees. So if this is 55 degrees, the whole of this is also 55 degrees. So this must be 40 degrees because there is already 15 degrees. Secondly, this 40 degrees here is an inscribed angle subtending arc ED, which is the same arc subtended at the center by 80 degrees. That's why this must be half of 80 degrees. So that is 40 degrees as shown. And 40 degrees plus 15 equals 55 degrees, which we already solved in another way that this should be alpha 70. So 2 alpha plus 70 is 180 degrees. So 2 alpha equals 180 minus 70, so 110 degrees. So alpha is 110 degrees over 2, so 55. That's why this must also be 55, but there is already 50 degrees here, so 40 degrees. That's 55 degrees. So in triangle ACE, the sum of the interior angles is 180 degrees. So theta plus 55 for this angle plus 40 degrees plus 50 degrees plus 20 degrees equals 180 degrees. Again, theta plus 55, this whole angle at E here, plus 40 degrees plus 15 degrees plus 20 degrees in triangle ACE is 180 degrees. 180, this is 95, 110, 130. So 180 minus 130 is 50 degrees. Another way of computing theta. Next is if we draw the lower half of the semicircle. So this is theta. If we extend in triangle ABE, ABE. So in triangle ABE, take note that AB is the diameter of the circle. So the measure of the angle AEB should be 90 degrees because these yellow chords subtend this semi-circular arc. The central angle is 180, so angle AEB should be 90 degrees. That is 55 degrees plus theta minus 15 equals 90 degrees. This angle between the yellow chords. So theta plus 15 degrees, theta plus 55 degrees minus 15 degrees must be equal to 90 degrees. Half of this angle, which is 180 degrees, is 90 degrees. So the angle between chords is 90 degrees. So theta plus 55 minus 15 should be equal to 90. Therefore, this is 40 degrees. 90 minus 40 is 50 degrees another way. Finally, if we extend this radius EO here, then because theta, assuming we do not know this, subtends arc DF, theta subtends arc DF, then the angle here, 30 degrees plus this angle, should be twice of theta. But we know this already, this is equal to 70 degrees. So meaning the whole angle here, central angle, which subtends arc DF, which is the same arc subtended at E by theta, should be 2 times theta. So 2 times theta equals 70 degrees plus 30 degrees. Then theta equals 100 over 2. So theta is really 50 degrees. So that's it. And I hope you can find a way by solving for theta in your own way by another one, and I will leave that to you. It's up to you how to analyze it, as long as it is not the same as the one I presented here.